Okay, now let us look at the behavior of the inductor as well as capacitor for transient response. Okay, now we all know that the inductor voltage equation is this, as well as capacitor current equation is this. So it is going to vary with respect to time. Okay, that's why d by dt is coming here, and of course these are derived from other laws in the nature, maybe Faraday's law, right? And here it is from the electrostatic energy or charge equation. Okay, so we got these voltage and current equations of inductor as well as capacitor. Now if you observe here, from this voltage equation of inductor we can say that the inductor doesn't allow sudden changes in current, and similarly capacitor doesn't allow sudden changes in voltage. But how to prove it mathematically? Let us see here. So let us say there is a sudden change. Okay, whenever some sudden change is there, what is the change in time? The change in time is 0, right? Because it is sudden. When something is sudden, there is no change in time, it is at a particular instant. So that means dt tends to 0. Okay, so for that sudden change, what will be the voltage equal to here? As per this formula, it is infinity, because dt is 0. So this voltage across inductor becomes infinity. So how you can see this particular condition? That means for sudden change in current in the inductor, the L, that means inductor, requires infinite voltage to be applied across it. So is it possible in reality? No, it is not possible. It is not practical. There won't be any infinite voltage source. So when there is infinite voltage source, you can expect sudden change in current. Since it is not possible in real time, it doesn't exist. So that is how we can prove that inductor doesn't allow sudden changes in the current. In the same manner, if you look at the differential equation of capacitor, what it is IC is equal to C into dVc by dt. So in the same manner, for sudden change dt tends to 0. When dt tends to 0, the current becomes infinity here, right? So when the current is becoming infinity means you need that much current to be flowing through the capacitor for capacitor to allow sudden changes in voltage, because here d by dt is there for voltage term. So again, that is also not possible. Infinity current doesn't exist in reality. So how to look at this condition now? It means for sudden change in voltage across capacitor, an infinite current is required, which is not possible. That means what is not possible? The sudden change in voltage across the capacitor is also not possible. So this is the proof for the inductor and capacitors to not allow sudden current as well as voltage across them respectively. Okay, this is a very important viva question as well as interview question. Whenever someone asks, you can say this reason. Right? Okay, that is fine. That is about sudden change. Whenever there is a sudden change, suppose that means you switch on the circuit, switch off the circuit. Under that instant, it is not going to allow sudden changes. That means whatever is there before switching action, it will be same after the switching action as well. But what is that variable which is same? It is the current in case of inductor, and it is the voltage in case of capacitor, right? These are the mathematical conditions saying that relationship. So inductor doesn't allow sudden changes in current. So from that you can say this IL of 0 plus is equal to IL of 0 minus. Similarly, capacitor doesn't allow sudden changes in voltage. From that statement you can say Vc of 0 plus is equal to Vc of 0 minus. So these conditions are very much useful while obtaining transient response, right? Okay, that is during switching operation. Okay, fine. So why we are keeping here 0 plus 0 minus, why not 2 plus 2 minus? Because we have considered the switching operation at time t equals to 0. Okay, we are considering that there is a switch in the circuit where L and C present, and that switch is being turned off at t is equal to 0 or are turned on at t is equal to 0. Anything is a switching operation only, whether you turn off or turn on. In the problem they will clearly specify. Okay, so that is about switching operation condition. Now we can have the condition in steady state as well. Okay, so what do you mean by steady state? In the steady state, that means there is no change in the current. Okay, otherwise even the voltage. If you consider capacitor, you can say in the steady state the voltage across the capacitor is constant. Okay, when they are constant, so what is the constant of d by dt? It is 0. That means in the steady state the voltage across the inductor is going to become 0. Similarly, in the steady state the current through capacitor is also going to become 0. Okay, so that is clearly written here. During the steady state the current value reaches a constant value and there won't be any change in it. So VL of infinity is equal to 0. So here infinity is considered as steady state time. So ideally it is considered as infinity, but practically it may be any time. Okay, after the transient response has been died, whatever is the steady state response, it may be any time, right? Ideally it is considered as infinity here. So similarly in the steady state the voltage across capacitor reaches a constant value. When that voltage is constant, I becomes 0 because d by dt of constant is 0. So we can write IC of infinity is also equal to 0. So from this steady state operation condition, what you can say about inductor and capacitor? So what do you mean by voltage equals to 0? Is it short circuit or open circuit? It is short circuit. So it means inductor acts as a short circuit in steady state condition. Similarly, the capacitor acts as open circuit in steady state condition. Right, so these two are very important conditions with respect to inductor and capacitor during steady state, and these two are the important conditions with respect to switching operation. Right, so all these conditions will be used while solving any problem in transient analysis. So but one thing people will always be confused or not clear about here is that, so we are saying during the steady state current is constant, but when we can say that, can we say it for only DC input or for also AC input? So we can say that in the steady state the current or voltage is constant or it is fixed only for DC input, because for a sinusoidal input it is continuously varying, the input itself is continuously varying. Okay, so this condition, steady state condition for inductor as well as capacitor are valid only for step input or DC input. Very important point, very important point, guys. So the steady state conditions are valid only for step input or DC input, right? So with this we will close this lecture. So very much useful conditions for solving the transient problems. Okay, thank you.